welcome to another episode here on the channel. Today's topic again is all mathematics, and if you've been kind of following through our current playlist, you'll see all of the new content that's either coming out on other playlists or the current content out on this playlist in particular. So right now we are tackling the statistic or probability side of mathematics. And so we're going to jump right into it like we usually do. So this question here is asking the following. Suppose the lengths of academic advising in a university form a normal distribution. The mean length of the advising is 8 minutes and a standard deviation of 2.5 minutes. The probability that an advising session will last more than 15.5 minutes is most nearly what? So, what we typically suggest on this channel is that you pause and you try and solve it on your own and come back and watch the rest of the video to get the answer. So, for us, we're going to go right into it, and this is pretty much something that's not very spoon-fed to you on the FE reference manual. You have to know where it is, and you have to know what you're looking at, and that's why practice always makes perfect, or at least for realistically excellence. So what you need to realize is that we are given several tidbits of information. We are given the value of, let me change my pen so that way you guys can actually see what I'm trying to write. That would help now, wouldn't it, y'all? So what we are given is the value of 15.5. We're given the value of 2.5, and we're also given the value of 8.0. So if you look onto the FE reference manual, you will find that most probability questions ask you for the value of X to even start to find it, and it will have you take the largest number, the second largest number, and then divide it by the smallest number underneath. So the largest number is subtracted by the smallest number and divided by that small number they give you. So for this particular equation, we know that 2.5 is the standard deviation. So the standard deviation goes here. We know that the mean length of advising is 8 minutes. Okay, so that one is this value that isn't what could be, it's what's the average. Okay, so the average value right there. And we know that the longest value goes here. So what we know from there is that the longest value is going to be 15.5. And so that's how we came up with this formula. Longest minus the average value over that standard deviation of 2.5. Of course, it goes without saying that all of these units are in the value of minutes, because if they weren't, this equation wouldn't work, and you're going to be talking about apples to oranges, so on and so forth. So, moving onward, let me clear the board here. What we need to realize is that this value here gets you to the number 3. Okay, so what do we do with that number 3? There is something called a normal, if I can write, that would be beautiful. You'll have a normal distribution. If my mouth could keep up with my pen writing, that would be awesome. I'm sure I'm spelling that right. Normal distribution, and then the last word is table. If you do a Control F and you try to find these tables, you will see what I'm talking about. So the thing you need to realize is that a normal distribution table, in order to read it appropriately, you have to do the kind of the checks and you have to be able to speak its language. And so this equation that I wrote earlier, and you can go back and you can even check the FE reference manual, this equation lets us calculate the 3 and then lets us go to the table itself. And because we know that information, then we can go to the table and we can look up what is 3. What we find is that based off of this, we know that we need to use R of X because the condition that this particular question is asking us is what is the probability that an advising session will last more than. Rx has a definitive, what's the right word here? R of x is defined as what is x to the infinity, okay? And so that's why we're using R of x. There are different variables also on that normal distribution table, and they're explained further up on the page, and we won't really go into it. We'll probably come out with another video kind of explaining everything, so on and so forth, so people can follow along. But we are being asked, because the important key question here is, will it last more than 15.5 minutes? So if x is greater than 15.5 minutes, what is the likelihood that it will last longer than that? So if we already know R of x, we know the 3, we follow along on that table, and what we can do is we can then come to know that the number is going to be 0.0013. Well, we're not done yet because it's not a percentage. What we know is that it is a 0.13%. And that is the likelihood that this equation will occur. And again, this circling that I'm doing right now comes back to this box because it's asking what is lasting more than 15.5 minutes. So 15.5 minutes, what's the percentage that that will occur? What we did was we followed along with this formula, which you can find on your FE, and I've kind of made a mess of it right now. Again, that is the longer portion of the more extreme portion of this scenario minus the mean length, or the mean of 8 minutes, all divided by the standard deviation. Realizing that the box is referencing this agenda, we know that it's R of x, and then you can follow along because with 3, because we've already calculated that, you go to the table, you use those values, you come to 0.0013, and that's how you go ahead and solve it. So if there's any comments, questions, or concerns, and you didn't quite follow along, let me know, and I'll make sure to come out with follow-up videos so that way we can attack it and make it to where everybody who's looking at probability and statistics doesn't have that problem anymore. So that's it. Make sure to leave a comment, like, and subscribe. Y'all have a good one.